if we're given a plot of capacitor current, we can easily find the corresponding plot of capacitor voltage. So in the first time frame here, from 0 to 10 milliseconds, right? So we have our equation for Vc of t, which is over here. Alright. So C is 50 microfarads, so 50 micro. And here we want a function of time for Vc of t. So we're going to have our limits go from 0 to t. In this time frame, the current is just 10 milliamps. So 10 milli goes right here. dt. So plus some kind of initial condition. Now they say in the problem that the capacitor is initially uncharged. So because they say that, you're going to just add 0 for 0 volts. So here Vc of t will be 200 t volts. And we also need an initial condition for other time frames that we analyze. So Vc of 10 milliseconds is going to be 2 volts. And that's just from plugging in 10 milliseconds for this equation over here. Right? So because this plot is periodic, if we analyze the second time frame right here, we'll get the exact same kind of equations, but just negative. And this will just repeat for however many cycles, right? So we know that in the first time frame, it builds up to a value of 2 volts total. So 2 volts right here. This is Vc of t and a value of volts. So it builds up to about 2 volts in a linear fashion. And then it will decrease in the same exact rate. And this is periodic, so it just happens over and over again. So we get the same exact thing over here in the next time frame, over here, and up here as well. And then it hits 0. So because it's 0, it has basically stopped charging, so we just get a flat rate of 2 volts over here. But yeah, this would be your final answer. So in this problem here, there's no switch involved, so we can redraw the capacitors and the inductors in their steady state models like this. They also tell us that the energy stored in between these two devices is equal. So we can solve for the energy here. We can use that to solve for C because these two values are equal. So here we go, let's go ahead and solve for it. So IL is going to be equal to just simply 12 over 200 plus 100 because everything here is in series. So we just get 40 milliamps. Right. So then Vc is just going to be 200 times IL. So we just get 8 volts. Alright, so the energy will just be 80 microjoules. And then by using the equation for the capacitor energy, C is going to be equal to 2.5 microfarads. Because this is equal to 80 microjoules. So you can just do some algebra and solve for C.